I mentioned earlier that sometimes frequency data have been recoded from interval data for display purposes. In this example, the question was, how many minutes does it take you to fall asleep after lights out? So once you've gone to bed and tried to fall asleep, how long does it take you to get to sleep? Let's assume we had 60 different responses. We might characterize those 60, or might summarize those 60 by saying there's a mean of 25 minutes, a median of 19 minutes, and a mode of 10 minutes. And those might all be true, but they're not necessarily a good description of the data. So this is an instance when it makes more sense to recode the interval data into categories and describe the category distribution. So if we look at the frequency by which people fall asleep in 5-minute categories, so each of these represents 5-minute groupings after lights out. And we see a bar graph here, and the bar graph sort of suggests that most people fall asleep under 30 minutes. But looking at the groups in 5-minute intervals doesn't give us a perfect or maybe the best summary of the data either. So here you see those frequency scores converted to a line graph of cumulative frequency. And the information in this simple graph is, I think, much more useful. So you can see that at about 25 minutes, 50% of the people report sleeping, and so that is consistent with our knowledge that 25 minutes was the mean. But you can also sort of look and say, well, it looks like 90% of the people fall asleep within 50 minutes, and only about 20% of the people fall asleep within the first 10 minutes. So I think for most purposes, this cumulative frequency graph would be most useful for this question. And what type of display is most appropriate depends on the nature of the question that's being asked. We can characterize or summarize samples of interval and ratio scaled measures with statistics that we characterize as descriptives. Descriptives provide us information about the central tendency of a set of data, the mean, median, and mode, and also the dispersion or the distribution of those data in terms of the maximum and minimum values, which is the range. They can be characterized in terms of quartiles or deciles. This value is 10% of the values are below this, 20% are below this, 30% are below this, and so on. But most normally in terms of the measure of variance or the square root of variance, which is the standard deviation. Variance is one description of a distribution of data. Two others that are important are skewness and kurtosis, which describe less the dispersion of the data and more the shape of the distribution of those data. So skewness refers to whether the distribution is symmetrical versus skewed to one side, and kurtosis refers to whether the distribution is high or flat, both of these relative to a normal curve. And most statistical packages will give values for skewness and kurtosis, and when a researcher is trying to describe the data, he will look at those values. For normal distribution, the values of skewness and kurtosis are both 0. For distributions that are skewed to the right, the skewness indicator will be positive, and for distributions that are skewed to the left, the skewness value will be negative. And for kurtosis, kurtosis is a higher level consideration, and it's not often crucial, but a reasonable cutoff is that values of kurtosis above 3 suggest that the underlying distribution is either too flat or too narrow to use the normal statistics. And violations of skewness and kurtosis have implications for measures of central tendency. For example, if a distribution is highly skewed, a distribution like income, for example, where the vast majority of people have annual incomes in the $40,000 to $70,000 range, but a few people have incomes that are in the millions of dollars per year. So a measure of central tendency like the mean will be heavily influenced by those outliers. It'll be pulled up. So with a violently skewed distribution, the median may be a better description of central tendency. Likewise, variance scores are affected by both skewness and kurtosis, and those variance scores are used to determine z-scores that are the crux of statistical testing. So with either severe skewness or severe kurtosis, as I say, there are questions about the appropriateness of those statistical tests. Fortunately, in marketing research, those issues are not too frequent, with one exception that I'll mention coming up, that being bimodal distributions.